Hey everyone, in this video I'm going to show you how to create a 2D outline shader using Amplify Shader Editor. This is a really versatile shader that can be used for a variety of purposes such as creating outlines for UI elements or sprites. I came across this amazing shader by Mirza on Twitter and I was really impressed with how easy it was to use. I got his permission to create a step-by-step tutorial and I'll be sharing with you that today. In this video we will start by creating a shader in Amplify Shader Editor, then we will create a script that allows us to control the outline by toggling it on or off when we hover over the sprite with our mouse cursor. This is Ramez Altabaf from Binary Lunar and let's get started. In this tutorial we will use Amplify Shader Editor, which is premium asset on Unity Asset Store. Currently there is no discount, so you can wait for discount on this asset, or maybe I'll try to convert this shader into shader graph very soon. But if you are searching for discounts, Unity Asset Store has released a new 30 items for $30 mega pack, where you can build a toolkit with this incredible collection of created assets and save up to 95% by buying this bundle. It contains a variety of assets from UI elements to shaders to sprite to 3D models to VFX, even full environments and many more. We will start by creating a normal 2D core project in Unity Hub, and let's name it Outline Shader Tutorial. Create a new project. Okay, let's start by importing the Amplify Shader Editor from the Unity Asset Store using the package manager. So if you have already bought the Amplify Shader Editor, you can go to the package manager, to your assets, and import that from there. Next, I've brought two sprites to experiment with them. I created those using Midjourney AI art, and those were part of my Unity online multiplayer course, which just released today on Udemy. First of all, let's create a new Amplify Shader. So let's right click, create Amplify Shader and select surface. Let's name it Outline Shader. Then we will get this Amplify Shader Editor window with the Outline Shader master node. We will choose the following settings for this specific shader. Let's keep the surface as it is. Standard. We can change to unlit because we will use the post-processing to give the glow effect. Shader mode 3 is okay. Precision float. Cull mode back, no need to change that. Render forward only. Next, we will create a script to help us with this shader. So we will need a custom expression node to use a custom script. It's like the custom script node in the shader graph. Go back to Unity Editor, right click anywhere in the project, click Show in Explorer, open the Assets folder, right-click, New, Text Document, and make sure that you show the extensions of the file by clicking View, Show, File Name Extension if you are using Windows 11. So let's create a new text document and change the extension to CGINC. Yes, and we can name it Outline Script. Open that using the Microsoft Visual Studio. I will not write line by line. We can go to the post shared by Mirza on Reddit. I'll provide the link for you down in the description, and copy his script and paste it in the outline script CGINC file. Let's save, and I'll give you a brief explanation about what this script do. This script has two functions. The first function is to get the neighbor with the largest alpha. The second one, we check if this is an outline or not. For checking the neighbor pixel with the largest alpha, we need a base texture, which is our sprite. We need a reference for the sprite UV. We need a reference for the texture texel size, which is the size of the sprite. And also we need a reference for the current alpha, representing the alpha areas of our sprite. And also we need a reference for the search width. We will search for every pixel, so we can say this value will be constant of 1. What is the outline width of the outline? So we assign the current alpha to a new float named alpha. Then we calculate the textual size of our sprite by dividing the outline width on the search width and multiply that with the base texture textile size, which is a property in our sprite. Then we do a for loop using all the pixels available in our sprite. So we go line by line using the X and Y values. So we do a loop for each column representing the X value and for each row of pixels representing the Y axis. But if we are this pixel, we ignore it because we need to search for the neighbor pixels, not this pixel. So if we are this pixel, we ignore it. Then we do an offset based on the pixel location and we multiply it with the texel size to get the neighbor pixels. Then we compare the alpha between the neighbors and current pixel and we choose the maximum between them. Then we return the alpha. Next, based on the current pixel and the largest neighbor alpha, we should the current pixel be an outline or not? So if the current alpha of this pixel is less than 0.5 and the largest neighbor alpha is equal or above 0.5, then we return true, means that this should be an outline pixel. If not, we return false. Now we can go back to the Amplify shader we created. Let's create a custom expression node. But before that, let's also change the render type to transparent because we will focus on the alpha of the sprite. Also change the render queue to transparent. Let's go down to the additional directives to include the file, the code file that we created. So let's copy the script name, outline script, go to the Amplify shader to additional directives and click the plus button here to add in another include and put the name here. Don't forget to add the extension, which is CGINC. Now we can get a reference for that script we created. Create a custom expression node. We can name it with the same name of the function we created. So let's name it getNeighbor with largest alpha. In the mode we select the create. Then we call that function by typing return and copying the function name here. Then we assign all the parameters. We can copy all the assigned parameters here. We just need the names and remove its types. So for the base texture, we remove the sampler 2D. For the base texture UV, we remove float 2. We remove the float 2 from here, the float from here, float from here. Okay, we have now all the parameters. Now we need to identify or giving references for those parameters. So the first parameter is the sampler 2D base texture. So let's give it the name base texture. The type of it is sampler 2D. Next we have a float 2, its name base texture UV. Next we have a float 2 base texture textile size. Next, we have the current alpha, which is just a float. Next, we have an integer search width. It's an integer. And finally, we have the outline width. It's also a float. Now we got all the required input parameters to continue with the shader creation. Make sure that the return with small letter and don't forget to add the semicolon. Let's add now the inputs. For the base texture, we can add texture object, and for that we will choose the sprite we created. So the texture to the base texture, and we can name it main text with M capital and T capital, so we detect automatically the sprite on the game object. Texture UV, we use texture coordinate, we connect the texture to it, then we get the UV from it and connect it to the base texture UV. For the base texture textile size, we use the textile size node, we connect to it the texture, and we connect the results to the base texture textile size. For the alpha, we get a sampler for the texture, so some texture sample T, and we connect the texture to it, and from that we can get the current alpha from the alpha channel. Then we can store the color of the texture in a variable, so register local variable, and we can name it texture color. For the search width, it's an integer. We can make it as constant, so it's an integer with the value of 1. And finally, for the outline width, it's a float. This is a property that can be adjusted from the editor. So it's a float, and we can name it outline width. It is a value between 0 and 8 based on the experiments. Let's set it to 5 for now, and make sure to set it as property so we can adjust it from the editor. Now we can save the output of the get neighbor with largest alpha into another variable. So let's register local variable, and we can name it with the same as the function neighbor with largest alpha. Okay, now we need to use the IsOutline functions, and for that we need another custom script node, custom expression node, and for that we can call the second function IsOutline. So let's copy this and put it in the code. Don't forget to add return with small letter at the beginning, and don't forget the semicolon. Then we remove the types of the parameters. We remove the float and the float from here. Now let's assign the parameter, and we can name it. We can name this function or this node as IsOutline. For the first parameter, it's the current alpha. It's a float, and the second one, the largest neighbor alpha, also a float. For the current alpha, we get the local variable, which is the texture color. We mask output component mask. We need the alpha channel only, so we remove all other channels. Then we connect it to the current alpha. Also, we get the second variable, which is the neighbor's variable, the neighbor's alpha. So get local variable, neighbor with largest alpha. We connect it here, and the output will be is the result if it is an outline or not. So we register this in a local variable. We can name it IsOutline. And finally, it's time to render the outline. To do so, we will use a Lerp node to lerp between the texture color. So get texture color and the outline color. So we need here a color node. We name it outline color. Set it to any value for now and connect it to the B. We will lerp between the texture color and the outline color based on if it is outline or not. So here we call the get local variable IsOutline, and we connect it to the alpha. Then we store the result in a variable. So register local variable, and we can name it final color. Then we use that final color. So get local variable final color. We connect that to the emission. And we get another version of it with masking all other channels while keeping the alpha, and connect that to the opacity, which represents the transparency of the sprite. Let's save and check if the shader graph working correctly. So here is our sprite. We need a material out of that shader. So let's right click on the shader, create material, outline shader, or let's say outline material matte. Then drag it on the sprite. You will see that we have the material, outline material. I forgot to set the color as property. So let's go back to the color here, make it a property and save. We can't see anything yet because the alpha of the color was 0. So increase that to the maximum. Now we can see the outline perfectly as expected. We can change the color of the outline. Also, we can change the width of the outline. To add the glowy effect, we need to install the post-processing package from the package manager. So go to the window, package manager, select the Unity registry, search for post-processing, install. Now we can go to the main camera. We add post-processing volume. When we create a new profile, inside it we override the bloom. We can set the intensity and threshold to 1. Then we add post-processing layer, and we can set to everything, but it says to set a specific layer other than everything and default. We can do that by going to layer, add layer. Then we can name this post-processing. Go back to the camera and set it to post-processing. Nothing post-processing. We can't see the glow yet because we need to set the color as HDR. So let's open the shader, and in the attributes, tick the HDR color, save, go back to the scene. Now increase the intensity to get the glow. If you still can't see the glow effect, you need to go to the edit, project settings, and check that if the use HDR has been enabled. By default, it's not enabled, seems on the 2D template. So let's uncheck the defaults. It will be checked by default. Uncheck. That allows us to change the use HDR. Just enable that for all the tires, the low and medium and high. And go back to the scene. We can see the glow now. So make sure to get the glow. You do the following. First, you need to set the outline color as HDR from the shader of the color node. Second, make sure that you have installed the post-processing, add post-processing volume and post-processing layer. And finally, make sure that you enabled use HDR from the graphics settings. So now we can control the intensity of the glow, the color of the outline, and everything is working now as expected. As an extra step, I created the code to control the outline widths when we hover over our sprite using our mouse cursor. So let's do that. For that, I created an outline controller script which have the following. We need a reference for the outline width on the shader. We need a float to control the speed of turning on the outline and turning it off. Also, we need a boolean to determine in which case we are turning on the outline or turning it off. By default, we set it to false. At the start, we get a reference for our sprite renderer and we gain reference to the material. Through the material, we will access the shader graph properties. In the update, we check if we're turning on the outline, then we call the outline on function. If not, we call the outline off function. Then we set the value of the outline width based on those two functions. So if we are turning on the outline, we set the IsOutline boolean to true. We check if the outline width is less than 8, which is the maximum value of the outline. Then we do a mathf.lerp to lerp between the current value of the outline width, which is 0 when we started. It moves slowly or based on the speed we determine toward the target, which is the maximum value of the outline, the 8th value. And we multiply the speed with the time dot delta time to do this smooth animation over time. The opposite, when the outline is off, we set the boolean to false and we check if we didn't reach the 0 value yet, which means the outline value is greater than 0. Then we do a lerp between the current value of the outline width toward the target 0, using the speed and over time. Okay, let's add that script to our character. So the outline controller is here. Next, we need to add some stuff to trigger the outline on and outline off methods or functions. For that, we need to add event trigger, and we add a new type of event OnPointerEnter, and we get a reference from our outline controller script to call the outline on. We add a new event for OnPointerExit, and again we call here the outline controller the outline off method. To be able to detect the sprite, we need a box collider 2D. We can make it smaller here in the scene, so maybe 8 or 6 by 8, that's good. And one more thing is that we need to create on the camera, to add on the camera raycaster. Physics 2D raycaster to detect the 2D colliders. And finally, we need to add the event system to be able to detect the collision. So let's right click in the hierarchy, UI, event system. Now let's click play. We should remove the outline. When we collide with the box collider 2D, we trigger on the outline. When we remove the mouse or we move out, we remove the outline, but it is very slow. We can adjust the speed from the parameters of the shader. So it's now 0.5, we can make it 5. Oh, now it's working perfectly. As an extra, you can add some sound effects. So here in the event trigger OnPointerEnter, we can add a sound effect by adding audio source. Then we call the audio source OnPointerEnter, and we let it call play audio source, play one shot, and we pass to it the sound effect. I have another sound when we go out of the sprite. So on OnPointerExit, we add the audio source and we call the play one shot audio clip, and we play the reversed sound effect. So let's check by clicking play. I'll increase the audio a bit, and that's it. Yes, we hovered over. When OnPointerEnter, we play the sound. When we leave, we play the other sound. I forgot to increase the speed of the outline controller. I set it to 5 again, hit play. And yes, we have this nice visual effect and also the sound effect. Voila! We now have everything working as expected for 2 different sprites. Maybe this is good for the character selection manager of your game. And that's it for today's video. If you enjoyed what you watched, you don't forget to hit like, subscribe and the notification bell so you keep updated with the next high quality tutorials. Let me know in the comments what you think about this video and if you have any other suggestions for the next video. Of course, we are deeply thankful to all our supporters on Patreon who keep encouraging us to keep posting high quality content and tutorials. The next video, see you soon.